Hey everybody, we're learning about molecular formulas next. So molecular formulas are a way to show how many atoms are in a molecule. They're really common. You'd know a lot of them already, particularly water, which is H2O for its molecular formula. So you should be able to write a molecular formula using chemical symbols from the periodic table, particularly for common molecules like water and carbon dioxide. Okay, a quick review about chemical symbols. We've learnt about these already, and remember that chemical symbols are found on the periodic table. And every element, all 118 of them, have their own unique chemical symbol. And each chemical symbol is always one letter or two letters. Sometimes they match the name of the element, like hydrogen here is H, easy to remember. Carbon is C, and chlorine is Cl. But sometimes they don't match the name of the element because they've come from ancient Greek or ancient Latin where they've used the Latin name for the chemical symbol. Also remember that when you have a two-letter chemical symbol, the first letter is capital and the second is always lowercase. So lithium is Li with a capital L and a small I. Copper is Cu. Gold is Au, which comes from aureum, which is Latin, and chlorine is Cl, capital C and lowercase l. So we're going to use those chemical symbols to build a molecular formula. You might also hear molecular formulas called chemical formulas. It's the same thing. So we often say the chemical formula for water is H2O. That's the same as a molecular formula, because it's telling us how many atoms are there in one molecule of that particular substance. And we use this thing called subscript to show how many atoms there are. We normally also have the elements in alphabetical order, but we'll come back to that in a second. So here are a couple of examples. Here's a molecule of hydrogen gas, a pretty flammable gas. They used to fill blimps with it. That's why the Hindenburg caught fire. It was full of hydrogen gas. It's very light, but it's flammable. So to write the molecular formula for hydrogen gas, you need to look at the molecule, and you can see it's got two atoms bonded together here, and both of those atoms are hydrogen. So to write the molecular formula for this molecule, we need to find the chemical symbol for hydrogen, which is H. And then we were going to write a small number to the bottom right, which is our subscript. And that shows us that there are two atoms of hydrogen in a molecule. Of course, if you have a whole container of hydrogen gas, you have trillions of molecules. But we're only looking at one molecule when we write the formula. Water is another really common molecule, which we've mentioned. So the chemical formula for water is H2O, and that means the number 2 here is relating to the hydrogen because it's to the bottom right. You can imagine that there's a number 1 down here at the bottom right of the oxygen, but we never write a number 1. So H2O, the formula, tells us that a molecule of water is made up of 2 hydrogen atoms bonded to 1 oxygen atom. And water has that classic Mickey Mouse head shape to it. So we normally write the elements, their chemical symbols, in alphabetical order. So for water, H comes before O. This doesn't always apply, but it's a good rule of thumb to go by. And you're not wrong to swap them over. OH2 is still water, it's just not the conventional way that we write it. We can also use a molecular formula to show how many molecules that are involved. And this is really useful when we start to write chemical equations, particularly in senior school. So to do this, we use a number at the front of the molecular formula. You can see in this example, there's a big number 2 at the front of the molecular formula for ammonia. And that number at the front tells us there are that many molecules in this example. So for ammonia, the molecular formula for ammonia is NH3. That tells us there is 1 nitrogen and 3 hydrogens in every ammonia molecule. And then if we put a 2 at the front, that means we have 2 molecules of ammonia. So here they are. Molecules can also be quite complicated, particularly when you start talking about biological molecules found in living things and things in our foods. So glucose is a common sugar that's in all foods that are sugary and sweet. It's a pretty large and complicated molecule you can see here. And the chemical formula for glucose is C6. So there are 6 carbons, the grey atoms here. H12, so there are 12 hydrogen atoms. And O6, there are 6 oxygen atoms in every glucose molecule. Hydrogen peroxide is another molecule, a bit more simple than glucose. It's a common cleaning product, and it's also the one that we break down to make elephant's toothpaste. So we've written out a molecular formula here. This tells us there are 3 molecules of hydrogen peroxide, and in each molecule of hydrogen peroxide, we've got 2 hydrogens and 2 oxygens. So here's 1 molecule here. The hydrogens are always small and the oxygens are large. And then we have 3 molecules in total. So that's how chemists use molecular formulas to show lots of information in a small amount of space by writing molecular formulas.